So what we're working on today is solving systems of equations graphically. We're going to go through several different ways to be able to solve our system of equations throughout this unit. First one we're focusing on is by graphing it. That's what we're doing today. First thing to know, system of equations is two or more equations that are put together. We're going to be sticking with two equations, but you can do three equations, sometimes even four equations, but we're not going to get to those ones. Other thing is, the whole point of why we're graphing is to be able to find the solution to the problem. And the solution is that point of intersection where the two graphs cross each other. As I said, that's the whole reason of doing it. If you don't find that point of intersection, then what are you doing with the problem? You're not doing anything. The whole reason is to find our answer, which is that point where they cross. So when we're graphing, we actually run into three different scenarios, and we're going to go through those. First one, you have two lines, so we want to graph them. Whenever we graph, we've got to remember to state our m and our b. Our m's in front of x, b is what comes after x. Remember, it's in that y equals mx plus b form that you did a lot last year. So we always want to state our slope and our y-intercept because you have to show work when you're graphing. If you don't show work, you're going to lose points. So stating these is our work shown. So we always begin with our b, which is our y-intercept. Since it's -3, we start at -3 on our y-axis. And then our slope of 2 means we go up 2 to the right 1. Up 2 to the right 1. Now you always want to have at least 3 points to make your graph accurate. I used 4. You can always use more. The more points you use, the more accurate your graph is going to be, but you need to have at least 3. Other thing you need to do is you have to include arrows on your graph because these do continue on forever, and you always need to label, especially when you are going to be graphing more than one equation on the same graph. So you need to label them so that you know and the person who's grading it knows which one is which. Now for our second line, we have a slope of 1. There's a 1 in front of that x that we don't write, but it is there. So our slope is 1, and our b this time is a -1. So again, we begin with our b at -1 on our y-axis. We're going up 1 over 1 this time for our slope. So I get my 4 points. Remember, you only have to have 3. I just put 4 to make my line a little bit more accurate when I go to draw it on here. You want to extend your line off of the graph, and then remember to write the equation of our line, y equals x minus 1. So as I said, the whole reason that we draw our graphs is to find that point right there where the lines intersect, which would be the points 2, 1. X always goes first, x and then y. So we went from the origin, we go to the right 2, up 1. That's where our point is. Now when you find your point, what you need to do then is you need to go back and check to make sure it's actually right, because sometimes we do make mistakes. So the way we check is we take our two lines and we plug in the solution that we got. So we're going to plug in 2 for x, we're going to plug in a 1 for y, and see if it works out. So when I plug it into this equation, I get 1 equals 2 times 2 minus 3. 2 times 2 is 4. 4 minus 3 gives me a 1. So it does work in that first equation. So now we need to try it in the second equation. Again, I'm plugging 1 in for y, 2 in for x. 2 minus 1 gives me 1 equals 1, which again, that does check out. So the point 2, 1 is in fact the solution to our system. Now another thing they want you to be able to start doing is being able to recognize if two lines have different slopes, which these ones had a slope of 2 and a slope of 1, so they had different slopes, they will always have one solution. So we can start recognizing from the equations themselves when we're going to have one solution by looking at those slopes and telling them that, being able to tell that they're different. So taking a look at our next example, again, we've got two lines, so we need to graph them. State our slope and our y-intercept. So my slope here was a -2, so it's -2 over 1. Here my b is a 1. So I start at the 1 and then I go down 2 to the right 1. Down 2 to the right 1. Still, the same rules apply. You need at least 3 points to make your graph accurate. So here I'm going to connect my points, and then I'm going to go through and label my line y equals negative 2x plus 1. And then I'm going to go ahead and graph the next one. It's negative 2 over 1. B equals negative 3. So as I go down, I start at my negative 3, and again, I go down 2 to the right 1. Now, I can't go down 2 to the right 1 again on this graph, so I'm going to go to the other direction, up 2 to the right 1. That's only okay when you run out of space. And again, I want to go connect my points, and then I'm going to label my line. Y equals negative 2x minus 3. So now what's going to happen this time is if you look at your two lines, those are never going to cross. Those are what we call parallel lines. So since they're never going to cross, this system has no solution. And again, if the lines have same slopes, here we had a slope of negative 2 and a slope of negative 2, and then they had different y-intercepts. Here I had a 1, here I had a negative 3. That's how I could tell already that my lines were going to be parallel, because they had the same slopes and they had different y-intercepts. So since I could already tell from the equation that they were going to be parallel, I could have already told that they were going to have no solution to them. And then our last scenario here, 2x plus 4y equals 8. We've got to get that into y equals form first. So I'm going to subtract my 2x, and then I'm going to divide by 4. So I get y equals negative 1/2 x, because negative 2 divided by negative 4 reduces to negative 1/2. We never want to use the decimal form of it, because the decimal is not going to do anything for us when we go to graph. We need the fraction to get our slope. And then 8 divided by 4 gives me a 2. So if I go up to this line and I state my slope, I have negative 1/2. I have a b of 2. If I go to this line, I have a slope of negative 1/2, a b of 2. They are exactly the same. My slope's the same, my y-intercept's the same. That means it's the same line. Since it's the same line, we say that this has infinitely many solutions. So what we mean by that is, since they are the same line, every single point on that line is a solution. And since the lines continue on forever, that means you have endless amount of points as your answer. In fact, we call it infinitely many. Now, as a little sidebar, if this video is going too fast for you, remember you can always pause it, copy down what I'm writing, and then replay to listen to my words. You got to make sure you do that if you need to. Okay, let's take a look at our back. They want us to tell whether the system has no solution, one solution, or infinitely many solutions. We don't need to graph in order to figure this out. What we need to do is make sure our lines are first in your y equals mx plus b form. So for this first problem, my second equation was not in y equals mx plus b form, so I'm going to make it so that it is by adding my 4 over. And then I'm going to go back and look. My slope of my first line is 1. My b value is 4. My second line, when I rearrange it, my slope is 1. My b value is 4. They're the same exact thing, so it's like that last problem that we just did. This will have infinitely many solutions. Now, the thing that you have to keep in mind going forward is they want us to explain how you know. When they put that word in explain in there, that means you need to write in words how you know. So we just put comma because they have the same slope and the same y-intercept. So that's how we knew it was going to be infinitely many solutions, because that makes it the same exact line. Taking a look at our second example over here, they're both in y equals mx plus b. So I'm going to state my slope and my y-intercept. So I have a slope of 2, a y-intercept of negative 3. Here I have a slope of negative 1, a y-intercept of positive 3. So looking at these, I have different slopes. So this falls under our first scenario that we had on the last page of notes. So this has one solution. And again, we have to explain how we know. So we write because they have different slopes. That's how we knew. Two equations with different slopes will always have just one intersection point. Okay, let's move on to our next type. Next one wants to know whether this point is the solution to the system that they gave us. The only way to find out is to take that point and to plug it into both equations. So I'm going to start with my 2x minus y equals 14. I'm going to start with my first equation, and I'm going to go ahead and plug in, keeping in mind x comes first, y comes second in our points. So I'm going to have 2 times 6 minus a negative 2. We're going to see if that equals a 14. Keeping in mind when I minus a negative, that really means I'm adding it. So 12 plus 2, that does in fact equal to give me 14. So that checks out. It works in the first equation. I'm going to test to see if it works in the second equation now. It's got to work in both in order to be a solution. So I'm plug my 6 in for x, my negative 2 in for y. So I get 6 minus 8, which that does in fact give me negative 2. So yes, it checks out. It works in both equations, so we have to write yes. 6 negative 2 is the solution. And again, we know it's the solution because it worked in both of the equations. So I'm taking a look at number 4. Same thing. I'm going to take the point 40. I'm going to plug it in, see if it works. I'm going to start with my first equation. I'm going to plug 4 in for x, 0 in for y. So I get 4 minus 0 equals 4, which in fact, that works. 4 does equal 4, because when you subtract 0, it's still the same number. For my second equation, again, I'm going to go ahead and plug in. So I have 4 for x, 0 for y. Well, when I have that negative sign in front of my 4, that makes it a negative 4 plus 0. So negative 4 does not equal negative 8. So since it did not work in both, we have to state no. 4, 0 is not the solution. And then for our last one down here, to kind of help save time, I already went ahead and graphed them for you. We had our two equations, so I graphed them over here in the graph. And so if you see, it doesn't fall in a nice spot, their point of intersection. It doesn't fall in one of the boxes like here or here. It falls in a little area, so you have to estimate your answers. So as I'm looking at it for my x value, I see I'm a little beyond halfway. So if I'm going to estimate, I'm going to say this is approximately a negative 0.8, because that's more than half. It's not quite all the way to negative 1. It's like in between the two, so I'm going to go with negative 0.8. For my y values, I know I'm higher than 2. I'm not quite at 3, but again, it's more than halfway to 3. So I'm going to go with about a 2.7. Now, since this is an estimation, if you have slightly different numbers than these two here, that's okay. The thing that's not going to be okay, though, is if you tell me like negative 0.4 and then 2.1. Those numbers are way too far off. Negative 0.4 is not even halfway yet through here. And then 2.1, again, that's down closer to 2. So that absolutely wouldn't work. You're not going to get the exact values when you estimate, but you need to be pretty close.